I need your magic note sheet to look something like this. This is what it should look like already. That you should have things like cosecant, tangent, cotangent, all of those ones, right? You know, that sine over cosine is tangent, and 1 over sine is cosecant. Like all those ones, those basic ones should be right up here, right? Look at I wrote it. Huh? I have no idea. Okay, so here's what I need. What I need you to write now is further down on your sheet. So I'm going to use Andrew's right here. You're going to write Pythagorean identities. And I'm going to show it to you. I'm just going to show you where you're going to write it. So you're going to write Pythag IDs. I'm going to spell that for you in a second. Right here. Identity. Do not write the circle. You don't have to write the circle. Just write Pythagorean identities. And then underneath that, I want you to do this. I want you to go line, 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 dot, 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 dot. Yes. It's a new type. So like just like that. Yeah. Yes. Yeah. Now I'm going to be honest. You're going to use these ones a ton for the next couple days. My goal is by the end of the week, you're going to be like my friend John back there and not really use this. You can have it as a security blanket, like if you can't quite remember it, but you can't really get good at these until you kind of have these in your head. Will you have them in your head by the end of the day? You will not. By Thursday or Friday, probably you will. So Magic is my TA A period. I had him as a sophomore. I had him as a junior. When we started this, the first day of this lesson, he literally looked at me last year and he said, I'm out. I can't. No, this doesn't make any sense. He ended up getting like 100% on the test. Like it comes, right? But it's been a long time since you've done something where it's like, I don't really get this. And some of you right away are going to be like, oh my God, I do get this. And it's kind of fun and I don't hate it. Some of you are going to be like, I don't get it today, but I'm not expecting you to be great at this today. I'm expecting you to be great at this by Friday. Okay. So that's the first thing. So here we go. Put your pencils down. Put your pencils down. I'm going to give you a formula. I'm going to give you 3 formulas today. I'm not a big believer that I just give you the random ass formula, but I'm going to do that on 2 out of the 3. But one of them, I'm going to show you why it works because it's the most important. So I've got Caden and I've got Danny and they're back there and they're working on their test and they have their unit circle, right? And on their unit circle, they may have like a 60-degree angle right here and they know that that's 1/2 and that's √3/2. And they're working away and that's awesome, right? That's awful looking. And here's what, for math to math, it has to work in all situations. It can't just work in some situations. So here's what I know. I know right now that this is a little baby right triangle. I know that. And I know because that is 1/2 and that is √3/2. And this is the unit circle that this guy is 1. If I wanted to Pythagorean this guy, a squared plus b squared equals c squared, I should be able to do it and it should equal 1. And I'm going to test it. I'm going to see if it works. Because right now, it's not looking good. I'm like, that doesn't look like it's going to work. So I'm going to try it. I'm going to say 1/2 squared plus √3/2 squared should equal 1 squared, which is 1. It looks shaky to me. Let's see what happens when I go 1/2 times 1/2. That's 1/4. Okay. And then I'm going to go √3 times √3, which is 3/4. 1/4 plus 3/4 is 1. It worked. It totally worked. And as a matter of fact, every single point on the unit circle would work. So here's what we know. What we can say now is this. This point right here is cosine, comma sine. You guys know that. That's how we did it. And watch what we can say now. We can say if you take this guy and you square him, and you take this guy and you square him, it every time, forever and ever, for the rest of your lives, will equal 1. Will equal 1. And it would be tan squared, but it will be 1. That is our first Pythagorean identity. So what I'd like you to do, we're going to start right here. Let me get rid of this dude. And let me get rid of this dude. We're going to start with this guy right here. Please write him on your line under Pythagorean identity. He is kind of the king of these. He's one of the most important. Now at this point, you're not used to him. You're not going to be watching for him when we do our little game. And you're going to, if you were playing the game with me, like who could do this faster, I would beat you every time because I recognize to watch for this guy. Here are some of his key features that in the next week you're going to watch for. The first thing that you're going to watch for is it will have squares. And it will have a plus or maybe a minus sign, and there will be a 1 involved. So when we do problems tonight, and you see something squared, and you see a 1, you're going to think, uh-oh, I bet that's one of those weird Pythagorean identities. Does that make sense? Now, this guy is the basic, but he's useful in other ways as well. Here's another way he's useful. Watch this. I am going to go ahead and I'm going to move cosine over there. So I'm going to say that, so this is my dot, sine squared theta equals 1 minus cosine squared theta. So I am going to watch for, if I see a cosine squared and a 1, I'm going to think to myself, hey, I'm going to go back to my magic note sheet. That might be something useful for me. It also works like this. Cosine squared theta equals 1 minus sine squared theta. Now, what you might be thinking is, Miss T, why the hell are you putting the squared in the middle? And here's why. We're not squaring the angles. We're actually squaring the operation of cosine. So that's why the squared goes here. Now, I'm going to take a brief side moment, and you're not going to write anything. You're just going to look at this and put your thing away. I want you to notice a couple things. These two problems are exactly the same. I write your homework. This is really good form. But you know what a pain in the ass this is for me to find theta on a typing thing? It's a giant pain in the ass. So often I use X's, but I don't want you to be like, Miss T, what happened to the theta? It's like, I'm too lazy to type it. And when we do our problems tonight, I get rolling, and you know what I even do then? I leave off the variable altogether, and then I just stick it back in at the end. Is that the right thing to do? No. But am I lazy? And I'll be like, oh, do sine, and then do tangent, and then you'll be like, what happened to the variables? It's like, oh, put them back in at the end. So I apologize in advance, right? So that's just a little bit of formality. Are we good with the first row? Sine squared, cosine squared, 1, big deal. Are we good? Okay. Moving on to your next column. Are you ready? I am going to get rid of this. I am going to get rid of this. Here comes our next one. Our next one is this dude right there. If you ever want me to tell you where it comes from, I can. But you don't really care. And that's okay. So, we're going to be watching in our little thinky heads for when we have secant and tangent and some squareds and a 1. Those are the important features, right? Squareds, and a 1, right? And the word tan and secant. Now, will it always show up like this? It will not. sometimes it will show up like this. And here's how else it can show up. It can show up as tan squared is equal to secant squared minus 1. Look what I did. I just moved him over here, right? And there's one other way that sometimes he shows up. Sometimes he shows up like this. Secant squared, minus tan squared equals 1. Now, I'll be honest. I was talking with my friend John back there. I teach this, and I still have to check on those. Sine squared, cosine squared 1, that one I got. I got in my head. I can move it around. I'm a pro. But the stupid tangent one, because the 1 is kind of in the wrong place to me, it messes with my head. So do I have a magic note sheet up here? I actually do. I could find it for you because I checked it this morning, right? Because I don't have this one memorized. But I know if I see tangent and secant, it's probably something. And then I go to my magic note sheet. Are we cool with that? Okay. There's one last one. Are you ready? Here we go. Let's get rid of what we got so far. Let's get rid of this. Let's get rid of this. Here comes the last guy. And right now, you should be thinking, I don't even understand how we're going to use this. And that's coming in a hot minute. Okay, here's our last one. He would go right here. Works the same way. What matters here is cosecant and cotangent are kind of buddies. And we got that 1. And we got some squareds, right? Those are the things we're watching for, right? And we can mix them around. We can mix them around. So on the first thing, I'm going to take this guy and hop him over here. So here's cotangent squared equals cosecant squared minus 1. And the last one is cosecant squared minus cotangent squared equals 1. Right? Again, do I have those ones memorized? I don't. And I do this for a living. For God's sake, if I don't have it memorized, don't worry about it. That's why I'm okay with you having a good reference sheet, right? You got to use them. You don't have to memorize them. But I would memorize the first group because we use those so much. Okay. You're going to slide this to the side. We're going to use it, so don't get rid of it. Get out either on your whiteboard desk or on your paper. Let's now do some problems. Are you ready? Here we go. Here's what our job is today. Our job, now, first thing I want to say, these are the same problem. This one's written nicely. This one's written not so nicely. And I might even be lazy enough to just go sine times secant, right? I'm that lazy. But here's the game that we're going to play for the next week. The game that we're going to play is this. What we are doing, and you want to put this on the top of your note paper, we are doing what's called simplifying trig identities. And here's the game. The game says this. If I gave you 4 plus 2, could you, as fast as me, write that in a smaller, simpler way? Could you? Yeah. You would write it as the number 6. Yay. That's what we're going to do today. We're going to take things that look long and scary. As a matter of fact, we're going to get to the point where they look like this. We're going to do this crazy one I'll show you right here. Oh my God, we're going to do that one. And it's going to simplify down to one tiny word. One tiny word. So our job is to say, can we make these into one tiny word? That's our job. So here's where we're going to start. Are you ready? The first thing that we do when we're doing these is we hate the word sine or anything but sine and cosine. Every other word I hate. I'm not going to lie. Do I like cosecant? No. Do I like secant? No. Do I even like tangent? No, I do not. So the first thing that we're going to do to simplify this is make it happier for us. So I would like you to look at your magic note sheet and rewrite this guy. Not using the word cosecant, using a different word. What's the word that goes with him? It is 1 over sine. 1 over sine. Beautiful. So I'm going to rewrite this guy as 1 over sine. Now, officially, it should be sine theta. I am lazy. I will start leaving off. I don't even like the word tangent that much. How can I rewrite him using the word sine and cosine? Sine over cosine. Sine theta over cosine. Have I lost anyone with what I just did? I just rewrote them using words I like better. And those things are right on your paper, right? Okay, guess what? We can cancel. So let's start canceling some stuff. This sign cancels with this sign. So what I get is 1 over cosine, which is okay, but there's a word for 1 over cosine. Look on your magic sheet. What is it? It is secant. And so I've taken this ugly mess and really it simplifies to be secant. That's what we're doing. It is very weird.
That's the whole problem.
That's it.
That's so easy.
If you know how to rewrite it, to be honest, it's not bad if you know how to rewrite it.
I'm like so.
You'll get there. I promise. I promise. You'll get there. So let's step back. Could you guys try this one now? No, it's the same thing. Get rid of this. Get rid of this. Try this. Rewrite it using only the words sine or cosine. If it's already got sine, yay for you.
I think we did do this first.
You did, but it probably didn't make a whole lot of sense. I'm going to say sine theta times secant, buddy, is cosine, right? 1 over cosine. I'm going to go across. I'm going to make it sine over cosine. Hey, I know what that is. Oh, good.
Just a bunch of numbers. Sine over cosine.
It is a bunch of logic. That's what it is. Okay, let's step up our game a little bit. Here we go. How about this one? Look how messy it is. That guy's going to clean up to be one tiny word. Give it a try. Rewrite those things. I only like one of those words. I only like cosine. The rest of the words I don't even like. Will you get better at these as you start to know these more in your head, that CSC goes with sine? Yes. Will you get better at these as that comes faster? Absolutely. Do I expect you to do it fast today? I do not.
It's just
Yes, it's just coast. Put it over 1. I love that. Now start canceling. I love that. Did you get 1? Is it 1? I love that. It's 1. Here's what I got. I got 1 over sine times sine. Oh, careful. Got a little trick here. I like you. It's sine square. It's tangent squared. So how many sines on the top do I have, and how many cosines on the bottom do I have? I have. Oh, sorry. Wait a second. I lied to you on this one. We gotta talk about this one. So it's cosecant squared. So that means it's 1 over not 1 sine, 2 sines. So you can either write it as sine squared, or what I do, sine sine. Why do I do it that way? Because it's easier to cancel. Tangent is going to be sine sine over cosine cosine. And finally, cosine over 1. How does that look to everybody? Are we okay? Okay, now let's cancel. Here we go. There we go, put your phone away. John, put your phone away. You can do whatever you want, just don't be rude. Okay, so here we go. Colton. See, down is not away, in your backpack. I have the chart. I don't want to guys start doing the chart. It's a pain in my ass. Okay, here we go. Let's cancel. Cancel, 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 cancel. Looks like I got 1 left and cosine on the bottom, which is CSC. Data.
We forgot to.
Is it secant? Sorry. God, so close. So close. I was feeling so cocky all day.
Because it's tan squared.
It's tan squared is sine, cosine, cosine. Nice, nice. Okay, let's step up our game a little bit. If you're like, what? Okay, so I love this one. First thing I'm going to tell you, we take care of the numerator and the denominator separately. So we are going to look at this guy, and then we're going to look at this guy. We're going to look at them separately. Now, let's look at the top. I could rewrite it, but I'm not going to, because this one has some hints in it for you. It's got squares, and it's got a minus, and it's got secant and tangent. Look on your Pythagorean list, because the squares and the minus are a clue. Right now, with your neighbors, look on your Pythagorean list. See if you actually can find this somewhere on your Pythagorean list. What is it? It's so nice. It is just 1. Secant squared minus tangent squared. You don't have to do any gypsy magic to it. It's just 1. But you have to watch for it, right? So it on the top is just 1. Now, with your neighbors, can you clean up the bottom? What are we going to do? We're going to go sine over cosine times cosine over 1. Do a little cancel action.
Sine over 1, so sine.
Awesome. Almost done. 1 over sine.
Is
That's it. Nice, Colton. Nice.
I'm clicking on it.
You are. I love these. Yeah, okay. Shut up. Yes, you do. It's only math you've done all year. How are we feeling?
Talk about it. I do math every day.
Okay, we got one last one that I want to talk about. Here's things. You can do certain things here. You can factor. You can claw. You can do all the certain things that we do. So we are going to try this dude right here. I love this dude. Let's see. Is this the one I want to do?
Yeah.
I think we're going to do this one. Okay. Here we go. So, first thing is, do I have to do anything to the denominator? I don't. So, here's what I want everyone to do. I want you to look at this guy. I want you to look at him. And I'm going to give you another problem. And I'm going to say this. If I gave you 5x plus x to the third, and I told you to vacuum something out of this guy,
You would vacuum out X.
I would vacuum out an x. You are fired. What would I be left with, Colton? 5 plus x squared. You are about to do the same thing. You are going to vacuum out 1 cosine. Are you with me on that? So I see, this is tricky stuff, right? So we're going to vacuum out the cosine. Are you with me? Here we go. So this is about as hard as it gets. Okay, do you see that this is I'm going to do it this way. This is some stuff, and this is some other stuff. You don't like it today. So, is there something that the yellow stuff and the blue stuff have in common? Is there a word that they have in common? Cos. So I am going to take it out. I'm going to take out the word cos. What I'm left with is sine squared, right? And I have taken, he had 3 of them. I took 1 of them. How many are left for him? 2. Are you with me? This is hard to guess.
I'm with you.
Now, sine squared, cosine squared, it's got squares, it's got a plus. Look at your magic sheet. Look at your Pythagorean, it's got squares with a plus, squares with a minus. It's 1. That shit all just goes away.
No way.
I'm almost done. Cosine over sine is a word. It is cotangent. This giant mess became this word.
I was about to say this.
Now I'm going to leave you with one final thought, and you don't have to do this one. Here's what. The final thought that I want to tell you is this. I did this problem, and we might do it again tomorrow. If I was doing this problem, me, Dana Tarantino, I would factor out the cosines. That's how I would do it. I had another student who said, Miss T, I didn't do that. I simplified this, and I went from there. And you know what happened? We got the exact same answer. So here's what I'm saying. If you have 2 plus 5 plus 7, you can go 2 plus 5, 7, plus 7 and get 14. Or you could go 5 plus 7, 12, and 2 more and get 14. My point is this. You might have a different way of doing it. The homework I'm going to give you, I did a solution key for. I showed you how I do it. But you might say to me, Miss T, I got the same answer. I did it different. And my answer to you is, that's awesome, right? So could you do it by simplifying this and then doing it? Or could you do it by factoring it? Yes and yes, okay? Will we spend more days on this? Yes. Is this weird today? Yes. So here we go. I'm going to pass out your homework. I definitely want to check at least the first 6 and one other one. But the more you do of these, the better you will get. So if you're like, Miss T, I'm good at these. I'm going to do some of the more bottom tricky ones. That is awesome. Okay? But you have to practice these. This is weird ass stuff. Like